Hello, I'm going to split the lesson 2 notes up into multiple videos because Canvas keeps yelling at me for having videos that are too long. So this is again lesson 2, it's for module 3 topic 2, so unit 7 that we started a couple days ago. So lesson 2 is all about the properties of exponential graphs and an equation that people often call PERT. We'll get to that in a moment. It has to do with continuous growth. So your basic exponential function is f of x equals b to the x. If b is greater than 1, it's going to be considered growth. If b is in between 0 and 1, it's going to be considered decay. So take a moment, pause the video, and try to figure out these couple functions down here. Try to decide if they are growth or decay. So just pause the video and decide if those 4 functions are growth or decay. So that first one, the b value is 4. 4 is greater than 1, so this would be considered growth. So I'm going to put a G for growth. That middle one, 2/3, is in between 0 and 1, so I'm going to put a D for decay. And then the next one over, 1/4, is in between 0 and 1, so I'll put a D for decay. And then that last one, 3/2, is the same as 1.5, so that's greater than 1, so I'll put a G for growth. In this next section, we're going to take our 4 functions and we'll put the 2 growth functions on the left and the 2 decay functions on the right. Let's call this one f of x equals 4 to the x. And then below that, let's do f of x equals 3/2 to the x. And then on the right side for our decay graphs, let's do f of x equals 1/4 to the x. And then the last one is f of x equals 2/3 to the x. I will do one of these with you, and then I'll have you pause the video and you could try the other 3. So for the 4 to the x in the upper left corner, we're going to say let x equal -1. So if I do 4 to the -1, that's the same as 1/4 to the, whoopsies, that's the same as 1/4 to the +1, which is just 1/4. And the reason I flipped that upside down is whenever you have a negative exponent, it's the same as doing the reciprocal, and then you change the sign of the exponent and you make it positive instead of negative. For the next one down, when x is 0, 4 to the 0 is going to be equal to 1. Anything raised to the 0 power is always 1. And then that last one, 4 to the first power is just 4. So on this little grid here, if I try to plot those points, when x is -1, I'm at 1/4. When x is 0, I'm at 1. And then when x is 1, I'm at 4. So some graph that looks roughly like that. So go ahead and pause the video and try to fill in the remaining 3 tables and then also plot all the points for the remaining 3 graphs. And then when you think you're done, continue the video and check your answers. Now that you have tried out the problems, here are the answers you should be getting. So I'll do 1/4 to the x. So if I do 1/4 to the -1, I end up flipping that fraction upside down, so it turns into 4. Anything to the 0 power is 1. And then 1/4 to the first power just stays 1/4. So when I'm graphing that, -1, 4, 0, 1, 1, 1/4. So it looks something roughly like that. So you'll notice the 2 that we have done so far, the growth graph is increasing the entire time, and then the decay graph is decreasing the entire time. And they look pretty similar to each other, just kind of flipped over the y-axis. Down in the lower left, f of x equals 3/2 raised up to the x. So when I raise that to the -1 power, it just flips the fraction upside down. So you're going to get 2/3. Anything to the 0 power is 1, and then 3/2 raised up to the first power will just stay 3/2. So when I'm plotting my points, -1, 2/3, 0, 1, and 1, 3/2. So it's still increasing the whole time, but it's not as steep of a increase. For the last one, bottom right, 2/3 raised up to the -1, you just flip the fraction upside down, so it's going to be 3/2. Man, it's going to be 3/2. Anything to the 0 power is 1, and then 2/3 raised up to the first power just stays 2/3. So when I go to plot it, -1, 3/2, 0, 1, 1, 2/3. So still decreasing the whole time since it's exponential decay, but now it is less steep compared to that one. The table down here at the bottom gives us a chance to talk about the key features of all basic exponential growth functions and then all basic exponential decay functions. So the domain is -infinity to infinity because there's no restrictions on the x values. The range is all our y values, little to big, so 0 to infinity since there are no negative y values. For an asymptote for growth, we would say y equals 0. And then for an x-intercept, there are none because there's that asymptote on the x-axis, so there are no actual x-intercepts at all. The y-intercept was 0, 1 that we saw in our table of values. And then for intervals of increase or decrease, we want to mark that it's increasing, and then it's increasing the entire time over the whole domain, which is -infinity to infinity. For end behavior, as x approaches infinity, f of x approaches infinity. And then as x approaches -infinity, f of x approaches 0. And we can see that, again, looking at our growth graphs. So as x gets bigger and bigger and bigger, your y coordinates are getting bigger and bigger and bigger, going towards infinity. And then as x is getting smaller and smaller and smaller, our y values are getting closer and closer and closer to 0, but they never actually touch 0. Pause the video and try filling out the second column for your basic exponential decay graphs. Now that you've tried the basic exponential decay graphs, check your answers. So -infinity to infinity for your domain, still 0 to infinity for your range, still y equals 0 for our asymptote, no x-intercept, y-intercept is still 0, 1, and then this is a little different. With decay, we're decreasing the whole time, so we want to mention that this is a decreasing interval, and it's decreasing for the whole domain, -infinity, infinity. And then for our end behavior, as x approaches infinity, f of x approaches, so if I look at my picture, as x is getting bigger and bigger and bigger, our y values are getting closer and closer and closer to 0. As x approaches -infinity, f of x, let's see, so -infinity. So as we get, our x values get smaller, our curve, our graph is going up. So f of x is approaching positive infinity. I'm going to stop this video here, and then we'll pick up in a second video for the second page.